So the last section in this module is on integrals, exponentials, functions, and logarithms. So this kind of comes back a little bit. Write the definition of the natural logarithm as an integral. I've already done that. We've already done that. Recognize the derivative of the natural log function. We've already done that too. Integrate functions involving the natural logarithmic function. We've done that. Define the number e through an integral. That I have not done. We can come back to that. Recognize the derivative and integral of the exponential function. Prove properties of logarithms and exponential functions using integrals. We've done that as well. And express general logarithmic and exponential functions in terms of natural logarithms and exponentials. So basically, we've done this section. So it's going to be a bit of a review. We're going to need the following integrals. So you guys should remember, if I integrate du over u, I get the natural log of u, absolute value of u plus a constant. And if I integrate e to the u, du, I get e to the u back plus a constant. That is the crutch of the whole section. Okay. So we're going to start with a few integrals, and I think that once you'll catch on to how easy these integrals are, okay? Number one. Okay, number one, what's u? What is u?
X2 to, wait, 6, x2 plus 9.
Okay, so u, 6x squared plus 9. What's du?
12x
12x what?
dx.
Dx. Okay, so what is x dx?
1/12 du.
Good. All right, so let's do our substitution. I have a 4. X dx, there it is, 1/12 du. Six x squared plus 9, oh, that is u. 4/12 is 1/3. The integral of du over u. What's the integral of du over u, guys? There should be a chorus of 25 voices.
Log u.
Okay. So there's 1/3, the natural log of the absolute value of u plus a constant. So my answer is 1/3, the natural log of the absolute value of 6x squared plus 9 plus a constant. All right, one down. Number 2. What's u?
3 minus x cubed.
Good. Du.
Would just be 3x dx.
How do you take the derivative of this x cubed, negative x cubed? First off, the negative has to be there.
Would it be 3x squared?
Okay, 3x squared. So we have to take the 3, subtract 1 from the exponent, gives us 3x squared, and what's missing?
dx.
Dx, okay. So therefore, what is x squared dx?
-1/3 du.
Okay, so here's my integral. I have a 4 there. X squared dx, you see it? Here it is, x squared dx. It's -1/3 du. What's in the denominator? So I get -4/3. The integral of du over u, same problem. -4/3. The natural log of the absolute value of u plus the constant. So what's my answer?
-4/3 natural log absolute value of 3 minus x cubed plus a constant.
Beautiful. Thank you, thank you. Number 3, we rocking through these, aren't we? What's u? What's u?
Tan x plus 6.
Tan x plus 6. What's the derivative of that?
Uh, 1/x² plus.
What's the derivative of tangent?
Secant squared.
Secant squared. Okay, Victor, you see that?
Okay, I think I was thinking of something different.
Yeah, I think you were making it too hard. Okay, I think I've got it all. I don't need to do another thing. There is secant squared x dx right there. So this just becomes the integral of du over u. Man, that one was really easy. Natural log of the absolute value of u plus a constant. So the answer is the natural log of the absolute value of the tangent of x plus 6 plus a constant. I skipped number 4. It'll run out of time. It's easy too. Number 5, I'm throwing you a curveball. Nah, I won't throw you a curveball. Let me not throw you a curveball because I don't want you to be. What's number 5? If I put an X there, then it's easy. All right, let's go on to number 6. Okay, what's u?
Would it be ex cubed?
Okay, it's just going to be the x cubed. Okay. Because we want to be able to have e to the u. Remember, we're trying to get e to the u. We want something that looks like e to the u. So that tells me u needs to be x cubed. Okay, keep going. What's du?
3x squared
3x squared what?
dx.
Dx, okay. So what is x squared dx?
1/3 is du.
Good. Okay, so now my integral, I have a 4 there. My e to the x cubed becomes e to the u. My x squared, here it is, that's the only thing left. X squared dx is the only thing left. That's 1/3 du. So this is 4/3. The integral of e to the u du. What's the integral of e to the u? Again, where's my chorus? What's the integral of e to the u?
X cubed.
Okay, you're almost there. You're making it hard. I want you to just give me the straightforward answer. The integral of e to the u du is e to the u. So this becomes 4/3 e to the u plus a constant. So my answer is 4/3 e, u was x cubed plus c. Okay, let's do number 7. Okay, so what's u?
Cotangent of x.
Cotangent x. What's du? Derivative of cotangent is?
Secant squared of, I'll go secant squared of x.
Okay, but it has a negative. All the codes are negative.
Oh.
So what is cosecant squared of x dx equal? What is cosecant squared of x equal?
Is it 1 over cosecant x?
Okay, trying to figure out why you're going so deep and making it so hard. If I just have this question and I just put the minus on the other side, I just get minus du. Because I'm trying to solve for this piece. So just put the minus on the other side. Were you trying to find a formula?
Yeah, I think that's what I was doing. But no, I
Okay.
see it. I see it.
You see it now? Okay. So now this is the integral. This e to the cotangent becomes e to the u. And cosecant squared x dx just becomes minus du. So I get minus the integral of e to the u du, but that is equal to minus e to the u plus a constant. So my answer is negative e to the cotangent of x plus a constant. Okay, one more. I told y'all going, this section was easy. Because we've hammered some of this into you already. Okay. This one's a fun one. I love this one. What is u?
Inverse tangent of x.
Tan inverse of x. What's the derivative of the tan inverse? This
Oh,
was
will
the
this
one you had to learn.
would this one be 1 over x squared plus 1?
Good. Okay. I think I see that in my problem. I do. I think I see that in my problem. There it is. So I'm done. This is the integral of e to the u, and 1 plus x squared in the denominator times dx is just du. This becomes e to the u plus a constant. So my answer is e to the tan inverse of x plus a constant. So those are the kind of problems I need you to practice for this section. Okay, you have recitation tomorrow. I have covered everything for the exam. The exam will cover integrals involving exponential and logarithmic functions, integrals resulting in inverse trigonometric functions. Oh, I'm sorry. I'm thinking y'all can see this. Y'all can't see this. Let me put it down here. I'm reading it, but y'all can't see it. There it is. That's exam 2. Okay, any questions? That's what exam 2 will cover. I'm going to try to get the sample one up today. It will not have all the sections, but it'll have most of them. Okay,
I have a question.
yes.
For office hours today, is it gonna be focused on the exam or what we learned today?
No, it depends on the questions. I don't plan to focus on, I'll only focus on whatever you want to focus on. I don't have to do this section, although some of these problems are actually basically what we did today is very much like section 1.6. But that I don't plan to target that on the test. So for office hours today, I will cover any topics that anybody wants to cover.
All right.
Okay. I'm open. I'm open.